Okay, we are in section 6.3. The law cosines. We're going to be looking at the law of cosines. All right. There's several forms of the equation for the law of cosines. We're going to solve triangles using the law of cosines. So there's three versions. A squared equals B squared plus C squared minus 2BC cosine of angle A. B squared equals A squared plus C squared minus 2AC cosine of angle B. And finally, C squared equals A squared plus B squared minus 2AB cosine of angle C. All right, those are the three versions of the law of cosines. All right, just making sure we can see all of it. So we're going to learn to solve triangles using the law of cosines. Using the law of cosines. Now, excuse me. They give us some guidelines, and you can read this in your text. We're just going to do a couple of examples, and I think it'll be pretty straightforward. And we'll use the law of cosines when we can't use the law of sines. Okay, we'll use the law of cosines when we have oblique triangles and we can't use the law of sines. So, the guidelines say we find the length of the side opposite the known angle by using the law of cosines. Once you find one of the unknown sides, then you can go back to the law of sines, the stuff we learned in section 6.2, because the law of sines is a little easier to apply than the law of cosines, all right? And if you want, you can take either one of these equations. Sometimes you're looking for sides, sometimes you're looking for angles. So if you took this equation and solved for the cosine of angle A, you'd have B squared plus C squared minus A squared all over 2BC. And I can do the same thing with this guy, same thing with this guy. All you're doing is solving the equation for the cosine of angle A. So you take these two guys to the other side. A squared is already here, so A squared minus B squared minus C squared. And then you divide by the stuff you don't want, all right? So we can solve for either one of these things that we want. Cosine of angle B would be A squared plus C squared minus B squared over 2AC. And finally, cosine of angle C would be A squared plus B squared minus little C squared over 2AB. So again, those come directly from those formulas. So you can use either form that you need. So again, let's just do some. Let's do example one. Example one. Example one in your text says to solve the triangle. Solve the triangle. And they say with angle A equals 52 degrees, they give us side B equals 22. Side C is equal to 35. That's the information they give us. Angle A is 52, side B is 22, side C is 35. So let's draw a triangle. And again, these are oblique triangles. They are not right triangles. That's hence why we're using the law of sines, law of cosines. And label it A, angle A, angle B, angle C. So if that's angle A, side A will be opposite. If this is angle B, side B will be opposite that. If this is angle C, side C will be opposite that. All right? So we'll write down what we know. We know that angle A is 52 degrees. We know that side B is 22. And finally, we know the side C is 35. So we have to solve the triangle, which means we find all remaining sides and angles. We'll find all remaining sides and angles. All right? And again, they say we will always start by finding the length of the side opposite the known angle. So I'm going to find the length of the side that's opposite the known angle. I know this angle, so I'm going to find the length of that side. Well, if I want A, and I know angle A, I'm going to use this first version of the formula. Which version of the formula you use is dictated by the information that you're given. So I'm going to use A squared is equal to B squared plus C squared minus 2BC cosine of angle A. That's the version I'm going to use. I'm going to plug in what I know. So I don't know A, so I'll leave this as A squared. B squared is 22 squared. Plus C squared means 35 squared. Minus 2 times B, 22. A, 35. And then the cosine of angle A, well, angle A is 52 degrees. All right? Okay. And you can take your calculator and you can do all these calculations. I'm not going to do it all. So I'll multiply all these numbers, square all these things, multiply everything together, and then this is A squared, so to get A, I'll take the square root of whatever the number is I have here, and I'll get 27.6. That's A. So A is 27.6. All right. Once you find A, now that I know two sides, now I can add one angle, now I can use the law of sines. I can use the law of sines to find angle B. So now we'll use the law of sines to find angle B. We'll use the law of sines to find angle B. So if you recall, the law of sines says that A over the sine of A, because I knew angle A, right? And I'm going to use the law of sines to find angle B. So I'm going to say equals B over the sine of B. Plug in what you know. So A is 27.6 over the sine of angle A, but angle A is 52 degrees. Is equal to side B. We know what side B is, it's 22. Over the sine of angle B. I don't know angle B, so I'm just going to write it out. Cross multiply. And then divide both sides by 27.6. And you'll get the sine of B is equal to, and do that math. Take your calculator, make sure your calculator is in degree mode, and we'll get, I don't know what you get, I don't really care. Well, I do care, but you know what I mean. 2 degrees over 27.6. And to get B, we'll take the sine inverse of that stuff. And if you do that, you should get that angle B is 38.9 degrees. And we're rounding, so I'll say approximately 38.9 degrees. All right. And the last thing to do is I don't know angle C, but now I have two angles to find that third angle. Angle A plus angle B plus angle C. The sum of all three angles in any triangle is always equal to 180. So angle A I know is 52 degrees. I do know angle B. Angle B now is 38.9 degrees. Plus angle C equals 180. Add these two up and subtract it from 180, and you'll find out that side C is 89.1 degrees approximately, rounding off to one place. So once you finish this process, we have solved for this triangle. We found all unknown sides and angles. Now, again, we found angle A, or side A rather, 27.6 by applying the law of cosines. I could not have applied the law of sines to this problem because initially I only knew angle A, 52, I knew side B, and I knew side C. I didn't know side A. So there was no way for me to apply the law of sines. So this is why we need the law of cosines for these oblique triangles where we can apply the law of sines. Now, once you get this unknown side and you find out that A is 27.6, well, then you can use the law of sines to find the remaining, that next angle, angle B. Now, you could have used another version of the law of cosines to find the rest of the information. But again, it is easier to apply the law of sines than it is the law of cosines. So once you get one of those unknown sides or angles, you'll usually go back and then you will apply the law of sines, just because it's an easier process and it's not as labor intensive. No other reason than that. Okay? No other reason than that. All right. So that's the law of cosines. Not difficult to apply, but please be careful because as you see, you're going to be doing about 6 or 7 calculations to do to find these unknown sides and angles, and it's really easy to lose a sign, make a very simple mistake. So be very, very careful. All right. Now, we can also use the law of cosines to solve side, side, side triangles. All right. So that's example 2. Use law of cosines to solve, they say side, side, side. Side, side, side triangles. Okay. In other words, they're going to give us the length of all 3 sides. They're going to give us the length of all 3 sides. An example of that would be example 2. Solve the triangle with side A equal to 24.6, side B equals 16.2, and side C equals 33.5. All right? Round to the nearest 10th of a degree. Okay, round to the nearest 10th of a degree. So draw an oblique triangle, label it A, B, C, and I'll do BC this way. Doesn't really matter though. But just so my scale is proper. So that's angle B, side B is 16.2. If this is angle C, then side C is 33.5. If this is angle A, then side A is 24.6. All right. So I know 3 sides, but I don't know any angles. Okay? I know 3 sides, but I don't know any angles. All right. Well, when you start this problem and you're solving this side, side, side problem, you will always want to use the law of cosines to find the largest angle of the triangle. So find the largest angle first. Find largest angle first. Part of the guidelines. Make sure you read through the guidelines. Well, the largest angle is going to be opposite the largest side. The largest angle will be opposite the largest side. So I'm going to find C. Find C. Angle C. Well, if I'm going to find angle C, then I'm going to use C squared equals A squared plus B squared minus 2AB cosine of angle C. And again, we said that we could solve for angle C, that alternative version of the formula. The cosine of C is equal to a squared plus b squared minus c squared over 2ab. All you're doing is taking that formula, solving for the cosine of c. So I'm going to use this version to find the cosine of c, and then I'll take the inverse cosine to find the actual angle c. So the cosine of c is equal to a squared, well, that's 24.6 squared, plus b squared, b is 16.2 squared, minus c squared. C is 33.5 squared. All divided by 2ab. A is 24.6. B is 16.2. Okay? All right. Well, take your calculator and work out that right side, being very, very, very careful. All right? Do all of this math on the right side, being careful. And they say, and then we'll take the inverse cosine so that C is approximately 108.6. Again, we'll work out all this math, and this is the cosine of C. So then we'll just take the cosine inverse of whatever that number is. This is 172, we're mature mathematicians, so I'm not gonna go through all those details. If you don't understand them, contact me, I'll be glad to show you. So now we have angle C. We have angle C, it's 108.6 degrees. 108.6 degrees. Once you get one of those angles, well, now again, we're back to the other thing where we can now solve for any one of those two remaining angles. I can actually find any one of those two remaining angles. And I can use the law of cosines to do it, or I can use the law of sines to do it. It does not matter which method you use, you gotta get the exact same value. I'm gonna use the law of sines because it's again a little less intensive as far as the mathematics. It's simple. So C over sine C equals B over sine B. I'm going to use that version of the law of sines, and I'm going to find angle B. Okay? So, let's just go ahead and cross multiply. And then divide by C, so that sine of B is equal to B sine C over C. Now plug in B. We already knew B was 16.2 times the sine of angle C. We just found angle C, that's 108.6 degrees, divided by side C. Side C is 33.5. And again, this is the sine of B. So to get B, you have to take the sine inverse of this stuff. To get B, you will take the sine inverse of that data. And the sine inverse of all that stuff will give you B equals 27.3 degrees. Approximately. So there's angle B, 27.3 degrees. Now again, you could have used the law of cosines to find that. It's equivalent. Once you find angle B, now you know two angles. You know angles C and angle B. So angle A will be 180 degrees minus the two angles you know, the sum of the two angles you know, plus that. So angle A will turn out to be approximately 44.1 degrees. And this is rounded, so I'll use the squigglies. So there's angle A. So we've solved this problem using the law of cosines. And again, use the law of cosines. We had no choice initially to use the law of cosines. We didn't have enough information to use the law of sines. We had to use the law of cosines initially, but once you find one of the two angles, then you can again either use the law of cosines again, or a simple process would be to go to the law of sines to finish the problem. All right. All right. Let's look at an application problem involving the law of cosines. Let's look at an application problem that involves the law of cosines. A Coast Guard ship, this is example 3. Coast Guard ship. They say it leaves its base at 16 knots. Leaves its base at 16 knots. A knot is a nautical mile per hour. On a course north 82 degrees east. On a course north 82 degrees east. 3 hours later, 3 hours later, a distress call comes in from a cargo ship. Distress call comes in from a cargo ship. All right. Located 180 nautical miles located 180 nautical miles, and these nautical miles from base at a bearing north 48 degrees east. All right, 8. Here's how to prepare the question. How far is the Coast Guard ship? How far is the Coast Guard ship from the cargo ship? Round to the nearest 10. All right, and then we'll finish this and then we'll do part B. So a Coast Guard ship leaves its base at 16 knots. Again, a knot, is a nautical mile per hour on a course north 82 degrees east. All right. 3 hours later, a distress call comes in from a cargo ship located 180 nautical miles from base. All right. At a bearing of north 48 degrees east. Okay. North 48 degrees east. And I want to know how far is the Coast Guard ship from the cargo ship. Okay. How far is the Coast Guard ship from the cargo ship? So one ship left its base at 16 knots on a course north 82 degrees east. So let's think about this. So let's write our bearings. This is north, this is east, this is south, that's west. And we're gonna call base this guy right here. There's base, the origin. The base is the origin. So one ship leaves its base at 16 knots, nautical miles per hour, a bearing of north 82 degrees east. So north and then 82 degrees east. So I measure an 82 degree angle. That ship's going in that direction. I I go north, 82 degrees from that in the easterly direction. And that ship traveled for how many hours? 3 hours. He's going 16 knots per hour for 3 hours. If he goes 16 knots per hour for 3 hours, 3 times 16 is 48. So he's traveled a distance of 48 nautical miles. That's that first ship. Okay. Now, 3 hours later, the distress call comes in from a cargo ship located 180 nautical miles from base at a bearing north 48 degrees east. So this guy, north 48 degrees east, and let me drop this down just a little bit. I want the triangle to be kind of representative of what we're looking at. So again, this is east, that's north, there's west, there's south. So again, the first guy, 82 degree angle, right? He went 48 miles. Second ship left base and he went 180 nautical miles. And his angle was north 48 degrees. So this is a 48 degree angle from there to there. Okay? And I want to know how far are the ships apart. So we're looking for X. We're looking for X. We want to know how far those two ships are apart. Okay? So let's label our triangle. So I'm going to just draw it over here. This is 48. This is 180. And again, just label your triangle however you want. I'm going to call it A, B, C, like this. A, B, C. All right. Well, if this angle from here to here is 82, this angle is 48, then this angle right here would be 82 degrees minus 48 degrees. All right. And that's 34 degrees. So this is a 34 degree angle. Angle A is a 34 degree angle. Okay, angle A is a 34 degree angle. All right. So there's the information I know, and I'm looking for side A. This is side C, and I'm looking for A. How far are these ships apart? All right. Well, again, I've got side C, I've got side B. I knew it was 48. I don't have side A, but I have angle A. Well, that's exactly what I need to use the law of cosine. I'm going to say A squared is B squared plus C squared minus 2BC cosine of angle A. Because I know B and C and I know angle A. So if I apply that, I can find A squared. Plug in everything you know. B squared would be 48 squared plus C squared, that would be 180 squared minus 2B, 48, 180, cosine of angle A is 34 degrees. That's A squared. Okay, that's A squared. Well, do your math. A turns out to be 142.8. And this is nautical miles. That's the answer to part A. How far are the ships apart? Well, they are apart by 142.8 miles. All right, 142.8 miles. All right, I'm gonna leave part B for you. It's not that bad. If you get confused, call me, email me, we'll do it. I'm gonna go on the Heron's formula. And that'll be the last thing in this section. Heron's formula. Heron's formula is used to find the area of a triangle. Okay. Find the area of a triangle. Okay. If you know, all three sides. That's what Heron's formula does. And so it says that the area is equal to the square root of S minus A, S minus B, S minus C, where S is equal to 1/2 A plus B plus C. That formula will find the area of a triangle if you know the length of all three sides. You're going to calculate S from the knowledge of the lengths of all three sides. Okay? So let's do one of these real fast. Example 4. Example 4 says find the area of a triangle. Find the area of a triangle with sides of length. They say A equals 12.2 centimeters. They say B equals 16 centimeters. And they say C equals 9.8 centimeters. Okay.
Can I introduce you to somebody right quick?